For point of interest, we calculate the derivative of the ax cubed function. We have here a graph of the ax cubed function, and we ask what's the derivative. Answers given in class started out with, well, we take the slope between 2 points, and we decide that those points ought to be symbolic. So the points ought to be x and x plus delta x. And we're going to take the derivative by taking the limit as delta x goes to 0 of delta y over delta x. And that is going to be, well, y is ax cubed, so that when we plug in x plus delta x to get the y coordinate at this point, we get a times x plus delta x quantity cubed. For this point, we get ax cubed. So the rise is going to be a times x plus delta x cubed minus ax cubed. The run is going to be delta x. When we put these in for delta y and delta x, we get this expression, which we have to simplify. Now, this expression is not too horribly difficult to simplify, but of course we have to cube that x plus delta x factor. When we cube x plus delta x, what we're essentially doing, well, what our strategy is we group two x plus delta x's together, and then another x plus delta x. We've already seen in doing the quadratic function how you square an x plus delta x. Of course, it was a t plus delta t at that time. X and t are used interchangeably for, or used in different situations for the independent variable. Anyhow, when we square it, we get x squared plus 2x delta x plus delta x squared, no surprise there, multiplied by x plus delta x. We distribute this multiplication through here, through this plus, and we get this term here multiplied by x, and then by delta x. We distribute the x through and we get this. We distribute the delta x through, we get this. I've been, actually it almost happened accidentally, I just wrote these down in the order they occur, but notice that our x squared delta x terms are lined up, our x delta x squared terms are lined up. So we're going to get what? X squared, 2x squared delta x, and an x squared delta x is a 3x squared delta x. Similarly, we get 3x delta x squared and an x cubed. And this is what we get when we cube x plus delta x. We then take the limit as delta x goes to 0. And you see things got a little bit cramped here, but we can still kind of read what's going on. A times the x plus delta x cubed. We just distribute the a through the expression we just derived, and then minus ax cubed. This little blotch here is a little cross out that I missed. And then we take the limit of that term as x delta x goes to 0. Well, the ax cubes are going to subtract off, leaving us this. Every term has at least a delta x here, a delta x squared, and a delta x cubed here. So that when we divide by delta x, we're left with 3ax cubed plus 3ax delta x plus delta x squared. These two terms go to 0 as delta x goes to 0, and we're left with 3ax squared, and that's our derivative. I'll note that it would have really been simpler to have factored the a out here. The a really could have been factored out of the limit, because the delta x doesn't have any effect on a. So that a is a common term to everything, and it could have just been factored out. That's an important idea that we'll see later.